So first I have to calculate the pH of 0.100 molar of monosodium phosphate, and then 0.125 molar of disodium phosphate. So then, and then the Ka of our dihydrogen phosphate is 6.2 times 10 to the negative 8th. And then we're going to calculate the pH after 0.050 molar of potassium hydroxide is added. So first going to be using the, for step 1, I'm going to be using the Henderson-Hasselbalch equation. So that would be pH equal to pKa plus the log times the concentration of the conjugate base over the concentration of the weak acid. So there's my equation. So first I have to solve for the pKa. So to do that, it's pKa is equal to negative log times the Ka. So pH is equal to, so I'm going to do negative log times our Ka of 6.2 times 10 to the negative 8th. And that's going to give us 7.21. So if I plug that in to our Hasselbalch equation, it's going to be 7.21 plus log times 0.125 molar over 0.100 molar. So there I have everything filled in. So now to just solve for the pH. Plus log 0.125 divided by 0.100. And that is going to give us a pH of 7.31. So now that we have our pH, we can do step 2 and add our potassium hydroxide to it by making a change table. So potassium hydroxide dissociates into just hydroxide, crossing out the K, and then so then I'm gonna write out our change table of hydroxide plus our weak acid of monosodium phosphate, H2P, and then our water and our H3PO minus. Okay, so here I have my starting of my change table right here. So let me write my, so it's our original concentration, then our change, then our equilibrium equations. So I'm going to fill this in really quick. So we have our hydroxide, which is 0.050 molar. Then our monosodium phosphate of 0.100 molar. Not paying attention to the water, 0.125 molar. And then we're going to subtract the 0.050 for the change. We're going to add it on our product side. Okay. So now once I add and subtract these, I get 0, then 0.050 molar, and then 0.175 molar. So now that I have these concentrations, I can plug that into the Hasselbalch equation again and get my pH after potassium hydroxide is added. So pH is equal to our pKa of 7.21 plus the log of 0.175 molar divided by 0.050 molar. So here's my equation set up again. And now to just calculate it. 7.21 plus log times 0.175 divided by 0.050. And that gives us a pH of 7.75. And you could tell that is correct because it is bigger than our previous pH. So here are the two pHs. So 7.31 for the first one, and then 7.75 for the second one.